You know, in the world of AI, things usually move pretty steadily. But every so often, you get these moments, two huge announcements right on top of each other that feel like they're pulling the future in completely different directions. Well, that's exactly what just went down, and we're going to break both of them apart.
So, on one side, you've got Hermes 4. Think of it as this giant open source model that's designed to think out loud. And on the other, Google's RLM, a super lean, hyper-specialized model that can predict how massive industrial systems will behave. What we're really looking at here are two totally different philosophies for where AI is headed. One is all about open, general-purpose power for everyone, and the other is about closed, surgical precision for industry.
All right, first up, Hermes 4 from Nous Research. Now, for the longest time, the big challenge for open source AI has been just trying to keep up with the complex reasoning you see in closed systems, like GPT-4. Hermes 4 isn't just trying to keep up, it's a direct shot at closing that gap for good.
The secret sauce here is something they're calling hybrid reasoning. And this is key. It's not just about being smart. It's about being smart efficiently and, maybe more importantly, being transparent about it. The model can figure out, hey, this is a simple question, I'll just give a simple answer. But it also knows when to roll up its sleeves and show you exactly how it's figuring out a complicated problem.
So what this really does is crack open the black box, right? When you ask it something tough, it literally flips into this reasoning mode and writes out its logic, step by step. This is huge because it means you get the right amount of detail every single time. You're not getting a giant wall of text when all you wanted was a simple fact.
So, how in the world did they teach it to think that deeply? Well, this is where it gets really creative. They didn't just go out and scrape the internet. Instead, they built this incredible data pipeline to generate its own training material, a massive amount of it, specifically designed to teach the model how to follow these really long, complex trains of thought.
It all kicks off with a system called DataForge. The best way to think about it is like a smart data factory for the AI. You can feed it something basic, maybe a Wikipedia article, and it will just spin that one thing into a huge library of complex problems and solutions for the model to learn from. It's pretty genius, actually.
But look, just making a ton of data isn't going to cut it. That data has to be perfect. And that's where Atropos comes in. Think of it as this brutally tough quality inspector. It runs over 1,000 different checks on every single piece of data. And if there's even one tiny logical flaw, it gets tossed out. Only the absolute best of the best makes it through.
Okay, so you've built this model that can think really, really deeply, but that creates a whole new problem, one I'm sure you've seen if you've ever used these models. They just don't know when to shut up. They'll just keep generating text until they blow right past their limits. The team knew this was a deal breaker they had to fix.
And their solution was pretty clever. They added a whole training stage that was focused on just one thing, teaching the model the stop signal. And the result? The numbers speak for themselves. They cut those runaway generations by a whopping 78%. This is a massive deal for usability. I mean, anybody can make an AI talk, but teaching it to be concise, that's the hard part. They taught it not just how to think, but just as importantly, when to be quiet.
And this chart, this shows you everything you need to know about their different philosophy. When tested on how it handles sensitive or controversial topics, Hermes 4 actually engages thoughtfully more than half the time. Now look at the competition. Big closed models like GPT-4 and Claude, they just refuse to answer way more often. Hermes 4 is designed to engage, not to run away.
Okay, so while Hermes 4 is out there pushing the boundaries of open source, Google has been off in a corner solving a completely different kind of puzzle. Their new thing, called RLM, isn't about general smarts. It's about tackling a very, very old problem in the world of massive industrial systems.
Just try to imagine predicting the performance of a Google-sized data center. I mean, the old way was a total nightmare. You'd have teams of people building these super delicate custom models. It was slow, it was expensive, and the second you change one tiny thing in the system, poof, the model would completely brick. RLM just throws that entire approach straight out the window. Instead of trying to clean up all the data and force it into these nice little tables, RLM basically learns to read the system's own language, the instruction manual, if you will. It takes everything, all the messy configs, the logs, the hardware specs, describes it all as text, and feeds that directly to the model. And the results of doing it this way are, well, they're staggering. RLM's predictions aren't just a little bit better. We're talking about a prediction error that is 100 times lower than the old models. This isn't just an improvement, it's a fundamental leap forward. It changes what's even possible.
And here it is. Here's the headline number. On Google's Borg data centers, I mean literally one of the most complex computing systems on Earth, RLM hit a peak correlation of 0.99. For a system this chaotic, it's practically perfect. It's pretty much unheard of. It's like giving engineers a crystal ball to see how their systems will perform.
So what this really unlocks is this idea of a universal simulator. Basically, any system you can describe with text, whether it's a cloud server or a factory floor, you can now potentially model and predict. It adapts to new things incredibly fast, and maybe the coolest part? It knows what it doesn't know. It can actually estimate its own confidence, which is a game changer.
Okay, so let's pull back for a second. What does this all mean? We've got these two massive breakthroughs landing at basically the same time, but they are pulling the future of AI in totally opposite directions. One is about democratizing intelligence, and the other is about perfecting it for very specific jobs.
And this table just lays it all out, side by side. You have Hermes 4, this absolute beast of a model at 405 billion parameters, all designed to bring that top-tier reasoning to everyone. And then you have RLM, which is tiny by comparison, just 60 million parameters built for one thing: surgical precision in industry. One is pushing open source to rival the giants, the other is creating a universal simulator for our infrastructure. So the big takeaway here is that AI's progress isn't this single straight line. It's a branching path, and it's leading to very different places. One path gives us powerful, transparent intelligence for everyone. The other gives us silent, almost perfect efficiency running the world behind the scenes. So the question I want to leave you with is this: as these two futures unfold, which one do you think is going to end up shaping our world the most?